So we start chapter 7 this morning, and we go back to talking about triangles. Up until now, most of our work here in trigonometry and Math 104 has been about right triangles. Today, we start talking about other triangles. So the first thing we want to talk about today is we want to review the congruency in oblique triangles. These should be familiar to you from geometry. Remember that two triangles are congruent if their corresponding sides and angles are equal, such as side angle side, if two sides in the included angle of one triangle are equal respectively to two sides in the included angle of a second, angle side angle, two angles and the included side, and then of course side side side. Remember, a triangle that is not a right triangle is what's called an oblique triangle. In a triangle that can be solved, the measures of all three sides and all three angles of a triangle can be found if at least one side and any other two measures are known. If you remember from geometry, knowing the angles of a triangle are congruent only help us to prove that triangles are similar, not that the triangles are necessarily congruent. We have to have a side involved. So what's going to happen, what we're going to have for these oblique triangles, we're going to have one side and two angles are known, either angle, angle, side, or angle, side, angle. You're going to have two sides and one angle not included between the two sides are known. This may lead to more than one triangle. You could have two sides and the angle included between the two sides are known. Side angle side. Or we could know all three sides are known, SSS. And again, notice in case 2, we write that as SSA because there is no S in Math 104. Again, if we know three angles of a triangle, we cannot find unique side lengths because triple AAA assures us only of similarity, not congruence. So, how we're going to do this is we're going to teach you something today called the law of sines. To derive the law of sines, we'll start with an oblique triangle, such as the acute angle shown on the left or the obtuse triangle shown below on the right. The discussion we have will apply to both triangles. We're going to first construct the perpendicular from B, vertex B, to side AC, or its extension. Let H be the length of that perpendicular. If you notice, triangle ADB, which I've highlighted in yellow on the acute triangle, and over here we're talking about BDC, then C is the hypotenuse of right triangle ADB, and A is the hypotenuse of right triangle BDC. So if we go back to our trigonometry, remembering that sine is the ratio of the opposite side to the hypotenuse, in triangle ADB, sine of A would be the ratio of H to C, or the height equals C times the sine of A. In triangle BDC on the right, sine of angle C would equal H over A, or H equals A times the sine of C. Notice that since H equals C times the sine of A, and H also equals A times the sine of C, we can set these two expressions equal to each other. So A times the sine of C equals C times the sine of A. And if we divide each side by sine A sine C, let me write this over here where I got a little more space. Sine A sine C equals C sine A divided by sine A sine C. The sines will cancel, and we're left with A over the sine of A equals C over the sine of C, and this is the law of sines. If we would have done this from other vertices, we can also show that the two equations are also true, and that is the law of sines. In any triangle ABC, A to the sine of A equals B to the sine of B equals C to the sine of C. That is, according to the law of sines, the lengths of the sides in the triangle are proportional to the sines of the measures of the angles opposite them. Now, we can go back, and you can even do this with right triangles. So instead of trying to think, hey, do I use sine? Do I use tangent? Do I use cosine? Do I use sine? We can just always do law of sines. An alternative form, because remember, in a proportion, you're allowed to switch the means and the extreme, or switch the, basically you're taking the reciprocal. So sine of A over A equals the sine of B over B, which equals the sine of C over C. So let's talk about our first case, when we know two angles and a side. So we're going to solve triangle ABC if A is 32 degrees, B is 81.8 degrees, and A is 42.9 centimeters. I always like to start my problems out. I'm going to draw myself a diagram. So 81.8 is going to make that almost a right angle. I'm going to make this a little bit longer. This is 32.0, so there's A, and A is 42.9. Remember, when you set up the triangles, you always label it so that the lowercase letter is opposite the larger, the capital vertex. So angle A, opposite side A. Here's angle B. That means this is side B, and this is side C. So step one, when you're doing an angle side or an angle side angle, is to find angle C. You've been finding angle C for a long time in geometry, because remember that the measure of a triangle is always 180 degrees. So it's 180 minus 32 plus 81.8. And if I flip out to Desmos, 180 minus parentheses, and if I could remember this, 32.0 plus 81.8. And we find out that angle C is 66.2 degrees. Answer 1. Now, we needed that because now we're going to do step 2, and we're going to find a side. Since you know all three angles, it doesn't matter. We can either do B or C, so I'm just going to go in order. I'm going to find B. So we're going to set this up with the law of sines, which says the sine of angle B to its opposite side is the same as the sine of angle A to its opposite side. Now, we had to use angle A because we know the opposite side of A. So if we put this in here, sine of 81.8 over the unknown side length of B is the sine of 32 degrees over its opposite side, 42.9. From here, it's a proportion. Now, my advice when you do this, don't round anything, put this all in your calculator. So we're going to take B times the sine of 32, cross multiplying, equals 42.9 times the sine of 81.8. We can then go ahead and divide by the sine of 32 on both sides. And we're ready to find our answer. So if I flip out 42.9, 42.9 times the sine of 81.8, close that parenthesis. Notice I'm in degrees, divided by the sine of 32. And I find out that that side is 80.1, in this case, centimeters. So I'll go ahead and mark that in my diagram. And then step 3, well, you got to find C, your other unknown side. Now, don't be tempted here, because you'll be tempted to say, oh, I've got two sides of a triangle, I can automatically use the Pythagorean theorem, because you can't, because it's not a right triangle. So again, we're going to set up the law of sines. So it's the sine of 32 over that 42.9. In this case, it's the sine of 66.2 over unknown side C. Again, we'll cross multiply. That's C times the sine of 32 equals 42.9 times the sine of 66.2. We'll divide by the sine of 32 on both sides. 42.9, so I'll go division, 42.9 times the sine of 66.2, close that parenthesis, sine 32. Looks a little big, so I noticed I lost a decimal point here, 42.9, making that 74.1. Now, when I'm done with this, I'm going to step back for a second, and I'm going to make sure that it's reasonable. So your check for reasonableness are two things. That is, the smallest angle is opposite the shortest side. Well, let's take a look at our diagram. 42.9 is the shortest side. It's opposite 32, the smallest angle. 66.2 is the middle angle, if you will. 74.1 is the middle side length. Yeah, the triangle makes sense from that standpoint. And 2, remember, triangle inequality says the sum of any two sides must be greater than the third side. So it's the sum of the two short sides that must be greater than the long side. So again, in my case, our case here, 74.1 plus 42.9 is over, it's like 117 exactly. That's greater than 80.1. Our triangle makes reasonable sense. So that's our first case of law of sines. In example 2, we're going to apply the law of sines in an angle side angle situation. This is what they do in surveying. If you've ever seen a surveyor out in the field, they're using triangulation to determine distances. In this case, they can't really figure out the distance across the river directly, but we can use trigonometry to help us figure it out. So they wish to measure the distance across a river, A, knowing this and this. So again, we're going to start out and we're going to find them angle B in this case. We're going to need angle B. So it's 180 minus the sum of 31.1 degrees plus 112.9 degrees. So if I clear my stuff here on Desmos, 180 minus, and notice how I use parentheses on Desmos? Because again, parentheses, we always know, as always, forces the order of operation. So I get that angle B is 36 degrees. And again, I mark my diagram. I just like to have my diagram marked up. Just makes it easier for me to visualize. So now we know the length of a side and the measure of its opposite angle. So that means we're going to have to do the sine of 36 over the sine of 36 is to 347.6, as the sine of 31.1 is to A. Now, You can also think, because you know triangle inequalities and you know the facts of triangles. Smaller the angle, shorter the side. So since 31.1 is less than 36, we know for a fact that our answer for A has to be less than 347.6. Just little helpful tricks along the way to make sure we get this right. So again, we're going to cross multiply. 347.6 times the sine of 31.1. And again, thinking ahead to your Chapter 7 test, which will be next week, this is how I would expect to see the work. Okay? I know you're going to use the calculators, you're going to punch up the answers, but I want to see the work. That way you can do partial. I can get partial credit if I need to. So again, 347.6 times the sine of 31.1 divided by sine of 36. And we get 33.04 feet. Yeah. If you think back to sig figs for a second, notice that these are all 2 decimal places. So we would give them 2 decimal places. Let me go back and check that answer real quick. Aha. Something didn't sit right with me because I thought, man, that's awful short. 347.6, 305.46. Much better. Again, think about triangles. 31.1 is not that far off of 36. Therefore, these two sides should be fairly close together in size. Because in an isosceles triangle, if two sides are congruent, if two angles are congruent, so are two sides. So I knew something didn't sit right. I did the check. Hey, that makes sense. That's reasonable. In example 3, we go back and visit our old friend, the bearing problem. So 2 ranger stations are located on an east-west line, 110 miles apart. They see a forest fire up here at C. One's located north 42 degrees east from station A. Remember, in bearings, you start out at the center. North means you're going this way, and you're going 42 degrees east of north. And the other bearing is located at north 15 degrees east. Well, that's all well and good, but now we get into our triangles. So this first angle, remember, if you do a compass direction, it should be perpendicular between north and east. So that means we have to do 90 minus 42. That makes this 48 degrees. This would be 90, which makes this entire angle 105 degrees. Let me see if I can clean some of this up a little bit. So again, this is a right angle. So that's 90 plus 15, 105. And 48. Remember back in geometry when we talked about the angle addition postulates? Now you know why we have to be able to do them. So the first thing we're going to need is we're going to have to, number 1, we need to find the measure of angle C. Again, it's a triangle. That means it's 180 minus the sum of the 2 angles that we already know. So I go into Desmos, 180 minus 48 plus 105. And we find out that angle C up here is 27 degrees. Now, to the nearest 10 miles, how far is the fire from the western station? Well, A is the western station, so we're looking for this right here. We're looking for B. So again, we can set up a law of sines problem. We know for a fact it's going to be greater than 110 because 27 is the smallest angle, therefore 110 is the smallest side. So it's the sine of 27 is to 110 as the sine of 105 is to B. And again, we're going to cross multiply, meaning we multiply diagonally B times the sine of 27 equals 110 times the sine of 105 We'll divide both sides by sine of 27. Back to Desmos. 110 times the sine of 105. Just to make sure I got the numbers correct in my head. Sine 27. 234.04. Now, make sure you read the directions as for what they want. They say to the nearest 10 miles. Therefore, our answer, 230 miles, rounded to the nearest 10. So that's using law of sines when we know angle, side, angle, or we know two sides. We know two sides and an angle. Other thing we want to talk about when it comes into law of sines is the area of a triangle. If you remember what you learned back in geometry and even back in middle school, is that the area of a triangle is found by taking 1/2 times the base times the height. So if we go ahead and write this triangle out fully, knowing that that height dropping down from a vertex perpendicular to a side forms two right triangles. So in this right triangle, the sine of A would be the ratio of H to C, opposite to hypotenuse, excuse me. So then multiplying both sides by C, we get C times the sine of A equals H. So if we go back to the 1/2 base times height and replace the height with C times the sine of A, we find a new formula for finding area. It's 1/2 times the product of the sides times the sine of the included angle. Doesn't matter which vertex sheet is. So if we fill this out, it's 1/2 the product and the measure. Let me get this. Half the products of the lengths of two sides and the sine of the angle between them. So here in example 4, we've got what we need. You got to have two sides and the angle between them. So the area in this case would be 1/2. Again, this is A, this is C, AC times the sine of B. A is 34, C is 42, sine 55 degrees, 10 minutes. So they threw that at us. So I put this in Desmos, times 34 times 42 times the sine. Remember, you can just let Desmos do your conversion, remembering that there's 60 minutes in a degree, so it's 55 plus 10 divided by 60, excuse me. And we find out that our area is 586.06. As far as a unit, you're talking area still. All areas are always square units. In our final example of this lesson, in example 5, before we can figure this out, well, we don't have enough to find the area yet because while we know two angles, we need two sides. So what we're going to do first is we got to do a little work with this. So we need to find side A or find side C. And of course, to do that, we're going to need to figure out what angle B is first. We're almost going to have to do a law of sines problem on this. So angle B, of course, would be 180 minus the sum of 24 degrees, 40 minutes, plus 52 degrees, 40 minutes. 52 plus 76, that's 80 minutes. So 76 degrees, 80 minutes. But of course, we wouldn't do that. That's 77 degrees, 20 minutes. So going way back, this is actually a good review for our final exam coming up here in a couple weeks. 180 degrees is 179 degrees, 60 minutes. So 60 minus 20 is 40 minutes, 102 degrees. Now, it doesn't matter which one we do this with, so I'm going to go ahead and do it for A. So that's the sine of 24 degrees, 40 minutes over A equals the sine of 102 degrees, 40 minutes over 27.3. So A times the sine of 102 degrees, 40 minutes equals 27.3 times the sine of 24 degrees, 40 minutes. So I write this all out here. So I'm going to go ahead and take this to my calculator. 27. Again, I start with the division, so it makes it a fraction. Times the sine. Again, I can't. 24 degrees, 40 minutes. So again, I'm going to let my calculator do that conversion. I don't care what it is. And then the sine, I believe it's 102 degrees plus that 40 minutes. 40 minutes, 60. Just to make sure I'm on the right track. Yep. So we find out that's 11.67754462. So in terms of like writing out a problem, I would know that this is 11.7, but I'm going to let my calculator do all the rest. So now I have two sides in the included angle. So it's 1/2 times 27.3 times that 11.7 times the sine of 52 degrees, 40 minutes. And look at Desmos. It's got that in there. So 0.5 times 27.3. This key below 3, the A and S key, I'm going to hit that, and notice it brings that last answer back up. And it's going to use it in my calculation. So that way I can still carry it out to the end. 52 plus 40 divided by 60. And again, all that part is doing is it's converting those minutes into decimal degrees. And my final answer, 126.7. 126.7. And again, since it's a area, it would be a square unit. And we'll go ahead and highlight that answer in green because it's the right answer. That, ladies and gentlemen, is how you do the law of sines.